Hi everyone, I hope you are doing well and welcome to another video series of MasterCAM, the complete course. So we have started the module number 2, which is all about the 2D design and tool paths. And we have covered the topic, which is creating 2D sketches and geometry and introduction to tool path and chaining manager. So let's get started and go to the next topic, which is all about the milling depth and cuts and milling lead in out and milling multi-passes, and some milling additional parameters, tool path type, and tool filter. So when you cover all these things from point number 3 to 7 in this video, so let's get started. So I have already opened the MasterCAM the Design 2023 version, and for that, all these topics we need to create some geometries here. So we already covered the 2D design using the wireframe tab. Let's get make some 2D geometries like rectangle, and I'm going to create rectangle and anchor to the center. Click here and give some dimensions. I'm going to make this dimension 150 and make this 90. That's okay. And we're going to make some ellipses at the center. Okay, the center point. And like that. So just to make this 8 point or 50 millimeter, and this point into 5. I pick this 35 millimeter. Okay. So we have created 2 geometries. One is the rectangle and the other is the ellipse. And give some round corners around it. We'll select the fillet. Like this radius to 10 millimeter. I mean, just give some running this chamfer or here. Whenever I use this 15 millimeter chamfer, this corner also 15 millimeter. So this is a very simple geometry, and you see that this is 2D geometry. So what we're going to do, we're going to study the milling depth cuts, okay? So you know that we create the 2D geometry. There is no thickness here. You can't see any thickness. This is a 2D object and we create this on a 2D plane. There is no 3D plane. We create this on a 2D plane. We have only the length and the width or the dia or radius, all these things, okay? We don't have any thicknesses here. So how we can create a thickness by using the machine tool path? Let's get started. So here we're going to go to the machine tab and we have the machining operations over here. So let's select the milling operation because we by default selecting the milling operation. And through the milling operations, we're going to perform the milling depth. Okay. So for that purpose, for the thickness purpose, and what operation you are going to perform on this is depends upon the milling operations you are going to perform. So for that, I'm going to create a cavity here. I'm going to create a pocket. And what I'm going to do is I'm going to create a solid on the outside. So we have a solid block around this shape and we have a pocket inside this. Let me show you how we can create this. So we have the tool path here, right click, milling tool paths, and what I'm going to do is I'm going to create a pocket here. So for that we got the wireframe chaining manager because we are going to perform the wireframe commands here, and we have to do this. So let's select the chaining method. I have selected chain. I'm going to select this because I'm going to create a pocket here. So I have selected the ellipse, click OK. And here we have the toolpath type. So I'm going to create a pocket here. And what I'm going to do is I'm going to select a tool. So as you know that we are going to cover the milling, depth cuts, laid in, laid out, multi-passes, and some additional milling parameter, tool path, type tools, and holders. So here we need to have a tool to cut this area, or we need to have a tool to cut this pocket like this shape, ellipse type shape. Okay. So for that you have to go to tool tab. This is what we call the pocket feature manager, or we can say that 2D toolpath features, and you can select the tab tools and go to filters and select the tool. So here we have different tools, and we can say that tool list is here. You can select them, you can filter them, the tools. For the pocket milling operation, we need the end mill toolpath. So we have the end mill, ball, low, spherical mill, and bone nose milling, face mill cutter, some radius mill cutter, and chamfer mill cutter, slot milling cutter, some tapered mill cutter, threading tools, turning tools. We have a lot of tools here. And some tool diameters. Here we have the HSS, carbide, tin coated, all these tools. So what I'm going to do, I'm going to select the flat end mill, and I'm going to uncheck the other tools. Okay. So I will only get the end mill details here. Okay. So select the tool library and we'll get the end mills tool here. So for that, I'm going to select the 5mm end mill. Okay. So I selected the 5mm end mill, and here we have the additional parameters for that. So the flat end mill diameter is 5mm, corner radius 0, and the length is 8mm, and the flutes we have 4 flutes. So there are 4 cutting edges, and we can say that it's a multi-fluted tool. We have 4 flutes, and the more the flutes, the more the cutting will be happen, and it will also depend upon the tool type, how much flutes does the tool have, and what operations you are going to perform. Depends upon the workpiece type, machine, and cutting feed and spade, and the tool which you are using. Either it's a high speed steel tool, or it's a tungsten carbide cutting tool. So it depends upon multiple factors. So we have the 4 flute tool, and you can change them by double clicking on it, and we can change the diameter, 5mm, overall length. You can add the length. By default, we have in market 5mm tools, which is around 15mm in overall length, and the cutting area is 8mm in length. So this yellow area represents that the cutter or the fluted area will be around 8mm. So all these parameters are depend on the tools which you have right now in your tool library, or in the physical form. You can add all these tool specifications here and get your work done. So shoulder length is 21mm, shoulder dia is 4.75. For the precision work, you need to add all these things. So next thing, you need to add the tool number, which is 215. So this is my first tool, so I'm going to give 1mm, and the tool length offset is 1mm by default. So it's a cutting speed is 339.0048408. So it's meters per minute cutting area, and for the material volt per tooth is 0.03K. So we have the fluted, 4 fluted. You have the 6 fluted. We're going to have 8 fluted tools. So by default, we got the fourth division market, and the feed rate, we want to change the feed rate. So I'm going to add the feed rate of 1500 millimeters per minute. And the plunge rate is 1000. You can calculate it by clicking on here to get by default cutting rate and the feed rate. So all these specifications from this to this area, the cursor I'm hovering over, you have to calculate them according to your machine, according to your workpiece type, according to your cutting tool specifications. Okay. So for me, I'm going to select the cutting feed rate of 1500 millimeters and the plunge rate of 300 millimeters. And the rotate speed is, you can make it 3000 because it will always rotate at a very high speed. So my machine spindle RPM is not 7000. My VMC machine has only 6000 max RPM. So I'm going to cut this pocket at a very high RPM. So therefore I'm going to add 6000. Okay. So you have to calculate all these things by using the formula, which is cutting speed is equal to pi d n over 1000. Then you can use this formula to calculate the cutting speed, feed, and all these are. Some material is carbide. So as I said, carbide spindle direction is clockwise. By default, we need to set the clockwise. So are you going to perform the roughing tool or the finishing tool or finish tool? So you can give some step over. Step over means that how much percentage the cutting tool will be used. Either you are going to use the 50% of tool or you're going to use the 20% of the tool. For example, the diameter is 5 millimeter and or the diameter is 2 millimeter. You can use the 50%. And then, for example, 5 millimeter is the dia of the cutting tool. So you're going to use the 50% of the tool. So you may set to 50%. It means that the 2.5% tool will be used. Okay. So you can add description, manufacturer, and tool code here and some tool gates over there. So let's click on the finish and we've got all these options here. Okay. So next thing is the tool folder. By default, you are using the tool. So there are multiple tools, holders. The tool perform, you can hold the tool in different type of holder, but it mostly depends upon the type of holder your machine comes with. Okay. So these are the HSK tool holder, and we have the H4S. These are the different ports here. You have to match them according to your machine spindle specification. Okay. And you have to select the appropriate tool holder for that. Okay. So there are different tool holders. And for me, if I go to, I'm going to use this, select the default tool holder. Okay. So I'm not going to add any different type of holder. So it depends upon the type of spindle which can hold the tool, or you will get the specifications from the manufacturer that this type of tool holder will be poured in your main spindle. So next thing is the cutting parameter. So we are going to perform the pocket milling operation, and this picture will represent that the cutting will be performed inside this pocket. So we have the pocket type is the standard pocket type. If we were to have the facing operation, then in this operation will be performed like that. And in and facing is that the cutting tool will be performed inside the land area and perform machining. And the remachining depends upon that. If you want to perform, you have previously performed a roughing operation, and you are going to perform and again machining operation, but on the remaining material which is not being cut by the previous operation, then you're going to select the remachining option. And for that, if in case you have a pocket which is open from the one side and you're going to make a pocket, then you're going to select the pocket open. Okay. So here we don't have any open area, or the pocket is not open. So we're going to select standard. Here is the machining direction. We have two options, the climb milling and the conventional milling. The difference between the climb and conventional milling. For the roughing operation, mostly select the conventional machining operation, where the cutting tool direction and the feed direction is different. And here we have the cutting tool direction in the climb milling, and the feed direction is different. So for the finishing operation, mostly we recommend that you need to use the climb milling operation rather than using the conventional milling operation. The next thing is the tip compensation, and we're going to use the tip to tip side to perform the cutting, or you are going to use the center of the. In this case, you need to have a bar nose or cycle type cutting tool to perform this. By default, we're using the end mill, which is a 5mm flat end. So we will select the option which is tip. And roll cutter round corners, yes, we'll need to sharp the corners because we don't need any shape around the corners. So therefore, we will make it sharp. So as you see that we don't have any corner here. We have already selected the round shape or ellipse. So by default to make sharp, or it will never happen on this area because we don't have any corner here. So linearization tolerance is 0.025. It's okay. And the most important thing is this area. So stock to lean on the walls. So if you want to layer some material, for example, this picture shows that we have a pocket area and we want to make some dimensions in the positive direction, and we want some material to be remained for the finishing operation. Then what we're going to do is we can add the material. For example, here we have the 1.0mm. So in this case, it will remain 1mm from this side, okay? And 1mm from the ground side. There is no such ground here, but it will remain material 1mm from the ground side. And if you want to remove some material from the wall, you can write it -1.0, and it will move in negative direction. For example, this path, and it will be remove 1mm from the outside of this boundary. For increasing the diameter or increasing the size, you need to add in negative. Okay. So let me, if you are going to make it 0mm from the ground or 0mm from the walls, and it will definitely never remove the material, but it will also follows the path and make your size according to the design. Okay, so it will never remove the material extra, or we can say that it will never leave the material, but it will make it 0 according to the size you have given in your design. So I'm going to show you by the example how it works. So the next thing is the roughing operation we're going to perform. Like this is a round shape. So what I'm going to do is I'm going to select an appropriate method of cutting. Like this is a zigzag. So this doesn't fit with my geometry. So how about the constant overlap? Yes, this makes some sense and make this spiral-like cutting. And this, the other parallel spiral, clean the corners, and morph spiral, high speed. one way or two spine. So this makes some sense according to the shape or according to my geometry. So let me select parallel spiral for this. So step over percentage is 50 millimeter, means it means that my cutting tool will take 2.5 millimeter. We are going to use 5 millimeter and min. So 2.5 millimeter will be step over, and it will take a step of 2.5 millimeter to perform another cut. Okay, so 50 millimeter is going to use. If we are going to add it 100 percentage, give 100 percentage, and it will 100% 5 millimeter tools will be a big step. Let me show you after clearing all these things. Okay, so the next thing is the entry motion, how it will be enter, it will enter like a helix, like this, in a helicity mode, or in a wrap mode, or in a off mode. So mostly we use the cutting tool to enter straight or perpendicularly into the workpiece. There are some certain conditions to perform in the ramp or in the helix. So we will discuss this ramp and helix in the coming videos. Let's make it off. And for the next step, we have the finishing. So we are going to perform the finishing operation. If you are going to perform a finishing operation, you can just click on the finish option and get the finishing operation done. So we are going to make one passes cutting. So let's make one, click one, and the space given is 2.5 millimeter. It will make a final one single pass and finish the operation. If there is any material remaining, like in the roughing or cutting operation, if you leave some or add some material here, it will finish the material for the finishing operation. Okay. The next thing is the lead in and lead out. The cutting tool, how the cutting tools will be enter into the workpiece, and after cutting the workpiece or make a job done, how it will be exit. So at this time I'm going to change the option, and I will discuss in the making a geometry here, and I will discuss it later. So for that, I'm going to uncheck this lead in or out option. For better understanding, I'm going to make another shape and let you know how it works. So how about the cutting depth? So we are going to perform the depth, meaning depth. So let's discuss the depth, how we can give the depth. So let me tell you that the cutting tool, how much it will cut in the single down. Okay, maximum rough steps is 2 millimeter. Mean to say, every step it will take 2 millimeter down in cutting material. So this depends upon the type of material you are using and the type of cutting tool you are using, and also it depends upon the quality of your machine. If your machine quality or machine is old, you need to have less the depth of cut. If you are using the high-speed steel over the textile carbide tool, then definitely you need to less the steps of depth cut. So in my case, let me show you that I'm going to make it 1 millimeter depth cut. Okay. In such case, I'm using the textile carbide cutting tool. So I'm using, and material which is I'm using is not enough hard, or we can say that we're going to perform this machining operation on a brass material or a copper material or aluminum material. So therefore, I'm going to use 1 millimeter depth of cut. And for the finishing operation, mean to say number of cuts in the finishing operation. And for the finishing operation, you know that we perform finishing operation to give accurate size and remove the burrs or lines of the cutting tools and make some shine in the object. For that purpose, you need to add the finish cuts. For example, in such case, I'm going to add 2 cuts. It will take 2 cuts to perform and remove 1 millimeter from the side. So here you see that we have the 3 lines here. It will take 2 steps to perform 2 steps and remove 1 millimeter from each side. So if I'm going to make it 0.05 millimeter, it will take 2 number of cuts and move the 0.05 millimeter material from the workpiece. Okay, so for the finishing operation, you can add different feed rate, you can add different single speed also. Okay, so by default, I'm going to perform this operation at 1500 RPM, 1500 millimeter per minute, and the spindle speed is 6000 millimeter, 6000 RPM, sorry. And what about the depth cut order? We're going to use the pocket order, not by the default, not by the in-depth order. Okay. So what we're going to do is the next thing is to keep tool down. In every step, it will be down. No, it will make the tool down direction and cut step by step. Okay, it will not go up and down then again. Okay, so it will take tool down in every step. Use island depths, make this uncheck subprogram. You want to create a subprogram. Then the subprogram is a different thing. If you want to perform each operation stepwise, then you can use this subprogram. But we're going to perform this default program, and we're going to make a single program for that. So therefore, I'm going to uncheck this. And the depth cut direction is step down. Definitely we need to step down. And if we're going to make the walls tapered, then you're going to give the taper angle, and it will definitely create a taper around this object. Okay, so we definitely uncheck this option, and we want to make this pocket straight at 90 degrees. Okay, so breakthrough is a different thing. We'll discuss in the later. Next, discuss about the linking parameters. And here we're going to set the depth of the this pocket depth. Okay, so the retract distance, the cutting tool will be retract to its original position after performing the operation is to 25 millimeter, and the cutting feed is the feed plane where it's going to start. Feed into the workpiece is the 10 millimeter. So I'm going to make it close, very close to the object. So let's make it 2.0 meter. The top of the stalk is this. This is the top, and by default it's 0.0 millimeter. So that's okay. So this is top 0.0. And what is the depth of this pocket? So this makes the object in a 3D shape, like this is a 2D shape, this is a 2D geometry, but it makes the cutting procedure in a 3D way. So therefore, we need to have the depth. So for that, I'm going to use the absolute system, where I'm going to use all these absolute system, not the incremental or associative modes. So we'll discuss the incremental, associative, or absolute modes in upcoming videos. So let's discuss about the depth. So let's make the depth in the negative direction, because this plane is a positive plane, this is 0. And in this negative direction, we have like that in downsize. So this is a positive Z, and we want to perform in negative. So from this point to here, we have the negative. So I want the depth of this pocket is minus 10 millimeter. So this will perform the cutting up to minus 10 millimeter in downsize. Let me show you. Click OK. Let me show some other options like home and references. You have to set the home and references for the machine. It's by default 250 in X, Y, and Z direction. For the arc, filter, and tolerance, make it default. Don't change this. We'll discuss in upcoming videos. How about the plane? So we have the top plane. How about the coolant? You are going to use the coolant to make the workpiece and cutting tool cool. So you can select the coolant option and click on. So M8 code will be on by selecting the fluid. And if you have the mist, then you can use other option. And here we have the some kind text. You can add some text. You can add some nodes here for the machining operation. Some miscellaneous values. Here we have some axis control to perform rotary axis. If you have a more axis machine like 4 axis, 5 axis machine, then this option is very helpful. We'll discuss this in next video. Let's click OK to generate the tool path. Click OK. So here you see that we got the pocket operation here, and we perform the cutting operation here. So let me show you from the top side. Right click, click top. So the distance between each tool path is 2.5 millimeter because we have selected that the cutting tool will only cutting tool percentage will be used 50%. So therefore the size of the tool path will be a 2.5 millimeters offset. So here we have the 2.5 millimeter, 2.5, 2.5, 2.5, 2.5, 2.5. And it will cut the material inside this polygon, okay? So according to your size, let me show you. And the depth is minus 10 millimeter. So here we have the 0 millimeter, and let me show you from the front side. So here you see that the depth is minus 10 millimeter, and it will perform two finishing operations. It will perform two finishing operations and move the material of 0.05 millimeter at the end. So we selected that the finishing operation and select two cutting steps and to perform move the material 0.05 millimeter at the end. And here you see that the yellow lines show that the feed plate, and here we have the 2 millimeter distance. Okay, so this is a 2 millimeter, and after 2 millimeter it will plunge into the workpiece and make some cut. So, and the depth of cut is 1 millimeter. So this is from this is 0 line, this is the top of the stock, and this is 1 millimeter, 2, 3, 4, 5, 6, 7, 8, 9, and 10 millimeter. So we take the depth of cut is 1 millimeter, so it will take 10 steps to perform 10 cuts, and at the last it will take 2 extra cuts for the finishing operation and remove the material of 0.05 millimeter at the end. Let me show you if we are going to change some parameters. Okay, go to parameters again, click and cutting parameters, and we're going to tell you about the stock wall leave. So let's start. If we're going to remove extra material, let me show you that I'm going to remove 2 millimeter extra from the wall thickness, and you'll see that the cutting tool path will be changed. So you see that the cutter will be work here, and it will remove extra material from the wall. And if we are going to we'll save some material from the wall, then let me show you in positive direction, in positive side. So it will save some material 2 millimeter from the wall. So this is how the stock wall leave works. So I'm going to make size accurate according to our geometry. So I make it 0.0 millimeter and the roughing side. So here we have the step over percentage. So we use the 5 millimeter. The distance step over is 5 millimeter. So each step is 5 millimeter ahead. And if you are going to use the cutter percentage 15 millimeter, it will use only 2.5 millimeter offsets with each with each depth of cut. So here you see that it will take 2.5 millimeter from each helix or each circle. Okay, so it depends upon the cutter, whether you are going to utilize your cutter in 100% mode or you are going to use the cutter 50%. So most probably we use 50% cutter for the cutting operation. It will save the cutting fluid. It will never get heat up. It will give finishing, and it will never remain some material. So therefore, we use the cutter 50%, 25%, or 20%. So it depends upon the type of operation you are performing. So the next thing is the spiral. You're going to change the shape. You can select this spiral. Okay, click OK, and you have this spiral operation over here. Okay, so you can check it whether what operation you are going to perform and what method you are going to cut your material. So for that, I just use the parallel spiral or constant spiral. So for that, if you're going to use the zigzag, it's never related to your geometry shape. It never fits with your geometry shape. So make sure that you have to select an appropriate method or cutting method according to your geometry. So for that, I'm going to use the parallel spiral. That's fit with the fit my geometry. Okay. So this is how we can set the depth of cuts. You see that we have the 2D geometry and we don't have any depth for the material, or we don't have any thickness for the object. So we can define the thickness by using the parameters or machining toolpath strategy. Let's discuss about the outside and contouring operation. Let me show you some other operations like the contour operation, and the selection method is definitely the chaining method. Click OK to get the chain and OK. So I'm going to use this 5 millimeter tool, and the milling RPM, spindle speed RPM is 6000. Feed rate would be a little bit high. This time I'm going to select the 2000, and the plunge feed will be 500 millimeters. Tool holder by default tool holder, and the cutting parameter. Okay, we're making default, and the cutting path parameter will be according to the shape we have selected. Let me know, and let's select again. Click contour, select the chain. Okay. And tool path type, we have the contour tool path. This contour tool path is used to create the profile of the object, whether to be cut inside or into outside. So it will only create the profile. And the tools 5 millimeter cutting parameters is, we have the 3D cutting parameter here. We have the 2D cutting parameters. And we also got the ramp cutting parameter, but here we don't have the ramp cutting parameter shown here. And yes, because we have selected the construction plane front, so therefore it's not showing that the ramp cutting operation. So let me make this once again. Construction plane top, and right click, create contour, select the chain. Okay, and tools, we got the tools. Spindle speed 6000. Feed rate is 2000, and the plunge rate is 500, and cutting parameters. So we have the type is contour. We got some more options here. 2D ramp. 2D ramp is like it will be follow like a helical cutting. You can say that it will cut like in the spiral in the spring way. Okay, and the depth will be make it 1.0 millimeter depth, and entry, lead in and lead out. So here I'm going to show you how the cutter will be enter into the workpiece and how it will cut the outside the boundary. Okay, let me show you that by default we have the entry, mean to say the cutter will, how the cutter will enter. Its entry will be tangential to the geometry. So the cutter, you know that we use the round cutter. So the cutter round profile will be tangential to this geometry, and the tangential geometry has the length of 100%, which is 5 millimeters. It's all about the diameter of the cutting tool, and the ramp height is 0 millimeter. And how about the arc radius is 5 millimeter? It will take like this. Okay, so the arc length will be 5 millimeter. So, and how about the exit? So we selected that the entry and the exit will be same. So therefore the exit and entry will be same, and I'm going to show you how it looks like when it cuts the creator toolpath. So breakthrough, we don't need a breakthrough. We'll discuss it later. And how about the multi passes? So this is same as it is like the finishing passes, but in a different way. So let me show you that we have this solid object here, and we want to perform multiple passes to cut. So we have the actual dimensions shown in this part, and we have the forge. In case of forging, so in case of forging, we have extra material outside the actual dimension. So we want to remove that material from the actual size. So therefore we create multi-passes to perform, to remove that material. For that purpose, we're going to select the multi-passes, and we want to perform the roughing operation. For example, I'm going to remove material in 2 steps. So it will take 2 operations at a space of 5 millimeter distance, for example, 5 millimeter distance, and it will take a finishing steps of 2 steps and clear the material of 0.5 millimeter, or I would going to make it 0.05 millimeter, and it will move 0.05 millimeter and take 2 finishing operations to perform this step. Okay, so keep tool down, it will make the tool down it always, and if we are going to perform this in a single way, it will do in a single way, and if we are going to make it in a zigzag way like this way, so it will perform. Let me show you after selecting the options. Okay, click on the likeness parameter. Here we are going to define the depth of the this geometry. So make it 25 millimeter. Retract feed plane is 2 millimeter, and the depth is -20 millimeter. So coolant, all these things will be default. Click OK. So what you see over here, that it creates a geometry here, and it takes a toolpath inside this geometry. So for that, we don't want to remove the material inside this geometry. We want to remove the material outside the geometry. So for that, you need to rechange your geometry, or you can click on the geometry and change the side. So I'm going to change the side. So here you see that the direction is inward. We can change the side, the outward direction. So this is outward, and we got the regeneration option. Regenerate the toolpath. You will get the toolpath outside. So here you see that it will perform two roughing operations and create two finishing operations to clear that material on that side. Okay. So this is how we can perform the multi passes operation and multi finishing operation to create that. So let me show you by performing this operation in a 3D way. So I'm going to select all this operation and let's go to machine and verify it. So I'm just click on the verify, and here we have the geometry. It will automatically create some block around the geometry according to the size. So let's get started. Click on the play button and you see that it will perform like that. So we have already selected that the wall thickness will be 0.0. We don't want to leave any material, or we don't want to remove any extra material from that geometry. So therefore it will never remove or leave any material. So here you see that it will perform multiple roughing operations to shape like that. So this is how we can perform the multi-passes operation. And here it does. Okay. So let me show you the lead in and lead out option. As I have told you that I'm going to show you how the cutting tool will be entered. So the entry point is shown in the green way, okay? In the green way. So this green path shows that the cutter will be entered like this, okay, tangentially, and it will cut the outside part, and after cutting the part, it will move tangentially to this point. So this is how lead in and lead out works. Let me show you in the slow version. Okay, so click the top view, going to show you the slow way. I'm going to slow down and show you. Click play. So the cutter is going like that. So this is showing that the cutter enters into the workpiece in a tangential way, and after performing all the operation, it will move outside. After performing all the operation, it will move or exit the tool path tangentially. Slow down. And you have to focus on this area, okay? So we are very near. Yes. So you see that the cutter exit in a tangential way, and the arc radius is 5 millimeter and the length is 5 millimeter or 10 millimeter. We have already set it. So this is how the lead in and lead out works. Okay. So hopefully you understand. If you don't want to perform in the exit or exit direction, just click uncheck the option, and it will enter in a tangential way and never leaves the tool path in a tangential way. It will directly do upward direction in a 90 degree, just like the pocket we have, just like we perform in pocket operation. Okay. So here you see that it will just enter in the tangential way, but never leaves in the tangential way. So hopefully you understand how we can perform, how we can set the parameters here So in this video, we have discussed about how to define the depth or milling depth cuts, milling lead in and lead out, and we have discussed the multi-passes and why we use the multi-passes, because we want to perform multi-passes operation on a forging or in a casting piece. So we have extra material on that, and for that purpose we need to make finishing operation and before our exercise. So therefore we use the multi-passes operation, and for the finishing or accurate sizing we use the multi-passes operation. So here we have discussed the milling depth cuts, milling lead in, lead out, and milling multi-passes. Some additional parameters like the tool path type we use, and tool and some folders, and some parameters we have set like the cutting speed and cutting fade, and what are the factors which depends upon the cutting tools or cutting speed, which are the factors which affects on the cutting speed or cutting fade. So we have the tool type material, we have the workpiece material, we have the operation which we are going to perform, we have the machine performance. We can say that how old our machine is, all it's a new machine or it's a old machine, and the specification on the machine. So all these factors depend upon the cutting speed and cutting feed, whatsoever we call it, the RPM, the machine, and all these things. So hopefully you understand all these points, and it will help you to perform the operation. So we started in the beginning of the study the design features like the 2D designing, and we'll go further and depth and discuss about the upcoming, which is the facing, pocket, slot, contour. We have discussed the pocket operation today and the contour operation today, but we'll discuss in depth about the facing, pocket, slot, contour, relay, motor chamfer, tool pass in the upcoming video. So thank you very much, and stay tuned for more information.